Waves 3 is interference. This is something that waves do. Now, the principle of superposition says that when two waves add together, we get a resultant, and the resultant amplitude at any point is the sum of the amplitudes due to each wave. So if you had this blue wave and this red wave, and they both arrived at the same place at the same time, then the resultant amplitude would be this green wave, and we get that by basically at any time just adding the two displacements together, bearing in mind that the displacement may be positive or negative. Okay, so here we have a point source. It might be dipping your finger in a ripple tank or something like that. A point source produces circular wave fronts, and these circular wave fronts radiate outwards, and point A is any old point. The waves are going to arrive at A, and at point A the displacement against time will be up and down sinusoidal due to this single point source. Now if we have 2 point sources, what's going to happen at A is that we'll get 2 waves arriving there at the same time. So what will happen at A? We will consider the case where the 2 sources are coherent. You need to know the conditions for coherence. 2 coherent sources, they've got the same frequency, so they've got the same wavelength, they've got similar amplitudes, and we will say that they are in phase. At least there's a constant phase relationship, but it's simpler to say that they are in phase. 2 coherent sources. So what will happen at A? And the answer is it depends. It depends where A is. What might happen is we might get constructive interference, which is when the waves add together and you get a very big resultant, or we might get destructive interference where the waves cancel each other out. If the 2 waves arrive in phase, then we will get constructive interference. If the 2 waves arrive in antiphase, then we will get destructive interference. Here's a screenshot from a FET animation. You should explore the FET animations if you don't know them, because they're very, very good. University of Colorado animations. And this one's called wave interference. You'll notice we've got 2 waves coming from 2 point sources. In some places there's a big amplitude resultant, and that's called a maximum. And in some places the waves cancel, and that's called a minimum. So there are maxima and minima. Okay, now it all depends on the phase difference. As I said, if they arrive in phase, then we will get constructive interference, and they will arrive in phase if the path difference equals n lambda, where n is an integer. So if the path difference is the difference in how far they've travelled. So if they've travelled the same distance, then the path difference is 0. If the difference is a wavelength, or 2 wavelengths, or 3 wavelengths, then the waves will arrive in phase and you will get constructive interference. Where do you get destructive interference is if the path difference is n lambda plus lambda over 2. Then they will arrive in antiphase and you will get destructive interference. Here's a summary of all of that. If you get a question asking you to explain, then make sure you use these keywords. Use all of these keywords. If the path difference is n lambda, the waves arrive in phase, constructive interference, strong signal. If the path difference is n lambda plus lambda over 2, the waves arrive in antiphase, destructive interference occurs, you get a weak signal. For any other path difference, it'll be kind of in phase-ish or out of phase-ish, and the resultant amplitude will be somewhere in between. Here's an example of a question you might be asked. In an experiment, a student walks past 2 loudspeakers which are connected to the same signal generator, and that basically means that they are 2 coherent sources. The student notices that the sound she hears gets louder and quieter. Explain why. And basically there'll be 6 marks for this, and what you need to do is write a coherent logical answer to it using all of them keywords, and I'm not going to do it for you.